Hey YouTube, my name is Mason and I made another programming language. This is the second one that I've made. The other one, I have a video up for it, but this one is a whole lot better. It took me a few months to write it, and there's definitely a bunch of kinks and stuff with it. I'm only one person, there's only so much I could really do with it, but this is kind of where I'm going to stop with it, and I have it up on my website. I'll talk about it and demonstrate it at the end. But I basically just wanted to show you guys what was going on with it and where it is, and I might just stop with it now, but we'll see how the feedback goes in this video. So yeah, I'm gonna go ahead and get into it. As opposed to my previous language, which was written in Java, this one has a backend of Python, and that gives me the ability to do a lot of cool things. So I'm gonna go ahead and show you some of the things that my language represents as far as Python's syntactical capabilities as well as improvements. So this script I'm calling MSNScript2, and it's a follow-up from my previous script, and it is factors better. And I wrote it because I thought of a concept that might actually be able to be implemented into real languages, and that is being able to write your own syntax. And while this doesn't actually offer much efficiency, it does allow the coder to have more of a personalized experience when writing, and can prove to offer more enjoyment when it comes to writing code. So again, the backend is Python, so I'm gonna go ahead and hop into the basics. So we have our normal print statement. If I want to run it, I type Python, because this is a Python backend script, so you do have to run the MSN2 interpreter by launching the interpreter and then specifying the file path of the .msn2 file that you want to reference and execute. So right now I'm running a little script called miscellaneous.msn2, and if I open up my Explorer over here, I do have my MSN Script Explorer, and what I'm running is under tests, and it's going to be miscellaneous.msn2. And if you're wondering where all of these files are, they're actually on my GitHub. I will link it in the description. But basically, we're running a simple little test. The file is right here. So to launch the interpreter down here, we notice that we are in the MSNScript2 directory, and this is where we need to be to run any scripts. So we're going to be here, and we're going to say msn2.py, which is going to be here. That's going to indirectly launch the interpreter. And after this, we're going to give another command line argument, which is going to be the path to the file. And this does or doesn't have to include the .msn2 at the end. So we're going to say tests/misc. We're going to run it, and the first run is a little slow, but that is going to go ahead and spit out hello YouTube. So MSN2 is kind of interesting. It will interpret the code line by line, and if it finds a line that is just Python syntax, it will go ahead and run that line using the Python interpreter. But if it finds something that's a little off or something different, then it'll fall back on the MSN2 interpreter, which will do its best to launch the code accordingly. So with that, I'm going to go ahead and get into some MSN2 syntax, granted that you understand Python. So the normal way to instantiate a variable is to actually use the @ symbol. So we're not going to do any of the normal Python syntax like this. We're actually just going to add an @ symbol in front of it to indicate that it is going to be MSN2. And then after that, it's going to be basically whatever you want. So we can just say name equals. And then whatever is after the equals will be interpreted recursively, so it can literally be whatever you want. It could be a string, or it could be another variable instantiation, name2 equals, and you can then go from there. So at the end, we'll just call it, I don't know, Mason. So to reference the value that's in a variable, you are actually going to have to say .val, or you can say val of a string. So this is going to return Mason, but my personal favorite is just saying, can't type, just .val, and more than likely the inside of these parentheses is going to take an argument. So actually in every single dot something called in MSN2, it does have to end in parentheses. So this right here will just get the value of the variable. So we can say print name.val, and this line, when interpreted, is going to be recognized not as Python, because this is not necessarily Python, because there is no name function that actually exists elsewhere. So this itself is going to just go ahead and print Mason. So this is where things kind of stray a little bit from Python. So if we wanted to say concatenate a string, normally in Python you would just say something plus something, and that would concatenate them, not name. And this would just concatenate them. But in MSN2, this is not how this works. This is purely functional. So in order to do this, we're going to have to reference a system call. And in MSN2, the majority of functions are actually system calls. So we are going to use the cat system call, and we are going to say cat, and this takes any amount of arguments, and we are going to go ahead and say name2.val, and in running this, we can see that this does function properly. In MSN2, there are a lot of system calls. The documentation is actually on my website, which I will have linked in the description, and you can actually test out the entire language on my website. There's a Python interpreter that I do have that I deployed with the website, and it has a little interactive little consoles that you can use to test out your own writing in the language. So I'm gonna go ahead and get into the next part of this, which is the variable or the methods that are attached to a variable. And there are also a lot of these, and I did that on purpose to be able to encase kind of all of the functionality that you would really need with any individual variable type. So for example, a string, it has basically all functions that you could probably think of. So let's say print something. What can we do? Even something like reverse. So something like this does reverse the string in place while also returning it. So if we go ahead and run this again, we are going to get the reverse string. Indexing in MSN2 is a little more following the same syntax as the rest of the language. If you want to get like a character of a string or an element of an array, all you do is use the .get function. So you can get at 0, and this is of course just going to get the first character, which is m. So another helpful thing that I did add into the language was a .print method, which just prints the value of a variable. So name.print with no arguments is just going to print the value of the variable. And print with one argument is going to print something that precedes the value of the variable. So name is, that's going to go ahead and print name is Mason. With 2 arguments, the second argument will follow. So name is that, and I'm 22. So, and I'm 22. And if you don't want anything preceding, then we're going to just put nothing. It's going to be Mason, and I'm 22. So throughout this tutorial, I may bring up a bunch of like methods or functions that I probably haven't mentioned yet, and I'll make sure to explain them as I'm writing them. So this is just a heads up that I may do that on accident. So I apologize before I end up doing this stuff, but let's go ahead and get into some more complex syntax. So another system call function that I would like to bring up that I was really proud of, I was inspired by JavaScript's callback function and thought that maybe this function could really just exist anywhere as any argument for anything, anywhere. So I'm going to go ahead and demonstrate. So maybe in instantiating a variable, I'm going to go ahead and call the system call. So this is it right here. Very similar to Java's callback, but it's just a equals and a greater than, less than sign. And that can take any amount of arguments, and no matter what happens with it, it will always return the value or the return of the last argument that it takes. So this is kind of like an inline function. So you can do anything you want in it, and it just returns whatever happens at the end. So if I want to, I don't know, do something in here at, I don't know, nothing, meso, and then, you know, I want to have another line going on, I don't know, I can add an n onto the end of it, and then I'm going to return the value of that variable, and then I'm going to go ahead and print the name, and that is going to just have my full name. Very quickly, I'm going to highlight how to make functions in MSN2. So there are a few ways to do this, but my favorite way is just using the function system call. The first argument is going to be the name of the function. The second argument is actually going to be the body of the function. And then the last, any amount of arguments over here are going to be the arguments to that function. So I'm not sure, we can say A and B, and then whatever's inside, I'm going to use an inline function for this. This will be what goes on in the function, but is not exactly what is returned. To specify a return, use the ret system callback. So this function and ret do go hand in hand, and you say ret to the first argument is going to be what you're returning to, second argument is what you're actually returning. So we can go ahead and say at added equals, I'm not sure, we can reference the op class here. So this is a special little thing that I implemented that does have like add, subtract, all sorts of different actual just mathematical operations. Just does whatever to any amount of arguments that's going on in here. So this, we're going to create a variable for the added arguments to the function. And A and B we can just reference as normal variables. So we can say a.val and b.val. And then we do have to end everything with a comma, because we have to remember we're still in the inline function. So this is still just an argument to the function. So we do have added being the added version of the two arguments, and what we're going to return to the function is just going to be the val of the added variables. Now of course we could have just put this right here and called it a day, not even had a inline function. We could have just put ret right here as the argument, but I'm just showing you kind of what's going on. So this is a function declaration, and we can use this by just calling it the normal way a system call would be called, and then with its arguments, so 3 and 4, and that's going to go ahead and add them together. Another helpful system call, hopefully the last system call that I'll go over, is going to be the end system call, and it takes one argument or no arguments, and is going to return a string version of the environment of kind of what's going on in the MSN2 interpreter right here. So I'm going to go ahead and say true, and this argument represents whether the environment is going to be printed or not. So I'm going to go ahead and say true, because we are still kind of in Pythonic syntax, so it does use true, false, 1 or 0. So if I run this, then it is going to print out the environment, and this is kind of all the the types that are going on in the interpreter backend. So you'll see these change as I go through this tutorial, but something simple I can say, just name equals Mason. Run this again, and we're gonna see that we do have one variable right here. So I did actually lie. I'm gonna go over a few more system calls. The first one I am pretty proud of as well. I was tired of having to do like all these weird things in Python to like start a thread. So in MSN2 there's just a thread system call, takes 2 arguments, name of the thread, and the second argument is going to be the function that is ran by the thread. So I can just include an inline function here, and this can say print hello from thread 1. I can include another one if I want to, as many as I want actually, that your computer can handle. And I run this is going to start 2 separate threads. Let's just do this and end. So I'm just going to show you a really small example of how semaphores can be used with these threads, and basically showing you exactly how thread control essentially works. I have a bunch of demonstrations up here under my demos folder up here, and there are a bunch of programs up here you can test yourself. Little more, tiny bit more complex examples with threads, but I'm gonna write for you a small little example. So if I go ahead and write a normal thread program, so thread t1 print thread 1 finished, have this down here, thread 2 finished. Now go ahead and run this. It's going to say thread 1 finished and then thread 2 finished because, well, we started thread 1 first and then thread 2. But what if we wanted thread 2 to actually finish first? To do this, you would simply create a little binary semaphore, so we can call that, I don't know, thread 2 done, and it's not going to be done. So we are going to have thread 1 actually use the wait command, and this takes 2 arguments, but I'm only going to go over where the scenario where wait takes 1 argument, and it's basically going to wait for a condition to be true. So in this case, it's going to wait for thread 2 done to be true, and then we do need a comma, and we're going to have thread 2 actually set this to true, so we're going to say thread 2 done equals true, and in having all of this, we're going to have thread 1 basically just wait for it to be true, and after thread 2 does print its thing, it's going to release this, allowing thread 1 to print that it is finished. If we go ahead and run it, we can see that thread 2 does finish first. So basically the reason that I actually implemented the thread system call, besides just the simplicity of launching a function under a new thread, was to actually start new processes. So that is done with the process system call, and I'm not going to go too deep into that, but there are a bunch of examples over here in my GitHub where I do launch new processes. Currently, these processes, or launching new processes, can only be done in Windows OS. I haven't yet done anything as far as Linux. But yeah, basically, yeah, the thread system call is used to launch new processes, and I needed to launch new processes because I wanted an easier way to launch API endpoints, and that can be done with system calls such as the endpoint system call. Again, all of the documentation is on my website, but creates really seamless creation of API endpoints. There's also a get, there's also a post, there's a whole bunch of good stuff for starting API endpoints and stuff like that, for making it really simple. But yeah, that's a basic overview of the multiprocessing, multiprogramming section of the language. So this is the concept that I mentioned at the beginning of the video that I really made the language for. I kind of just made the processes, threads, endpoints, additions along the way, but these 4 system calls grant you the ability to create your own syntax. And I'm going to explain about every one and only demonstrate a few of them. But yeah, the first one I'm going to go over is the macro system call. So in words, the macro system call takes the first argument as a string, and wherever it sees it later in the code, it will invoke it will actually just place whatever this string is into the second argument as a variable. So I will call this line. And whatever the third argument is in the macro is the function that will be executed given that the interpreter sees this macro and it has something after it. So basically, to put this into code, I am going to say that whatever this preceding macro, or whenever it's seen, is going to place whatever is after it into this variable name, and then the third argument is going to be executed as a function. So you can probably now see kind of what's going on, and this little line of code right here is just going to print hello, and there you go, it does print it. But so we see that it does have a space before it, and let's say we don't really want that space. So instead of that, we are going to use an inline function to specify multiple lines, and we are going to say that, not print it just yet, but we are going to strip the line, and then we'll print it. So this function is going to be invoked because we have invoked it right here. That is going to go ahead and strip it and print it. And this macro is going to stick throughout the code, so I can actually invoke it as many times as I want. I can say, hello, my name is Mason. And this macro does not have to be just like a baseline of code right here. It can actually be basically anywhere. This is another line, and this is another. So go ahead and run these. It's going to go ahead and print all of these as I just specified. And you can kind of see now how the macro call works. And now I'm going to go over some of the other syntax altering system calls. So now I'm going to go over the post macro system call. And before I go over that, I'm going to go over the assertion system call. So it basically just makes sure that all of the arguments do evaluate to true. So if I have a bunch of trues in here, I run this, it's going to do nothing because this assertion succeeded. But if I do have any 0 or false or anything that evaluates to false, it will go ahead and say that it did fail. So now that we know that, I can go ahead and demonstrate the post macro. And just like the macro, instead of something needing to be in front, this macro is invoked if it sees something after a line. And again, this can also be anywhere in code, literally anywhere. It could be like right here, like it really doesn't matter, it could be anywhere. So for this one, I have a specific implementation for the post macro that I do like to use, and it's just question marks, and this question mark will ask if the preceding line evaluates to true. So this is going to be post macro, have a variable and then a function. So there is another system call I would like to go over. I really said that I wasn't going to talk about anymore, but there is one that I like to use. It's just a dash, and it evaluates any string line of MSN code as a string. So if I had this Mason and I run this, it's going to interpret this as a string and just basically run whatever's inside as MSN2 code, not Python code. Well, it could be Python code, but it might fall back. So I use that in cases like this when I am altering the syntax and I do just have a string version of code. So I will say I would like to assert that whatever is interpreted, whatever the line is, given that it will be MSN2 code, I will assert that it is true. So line.val, and we actually don't need an inline function for this. We can just go ahead and do this assertion post macro. So now this allows us to no longer have to use assert if we're testing something. We can just say like 2 equals 2, and that is going to be true. But we could say like, I don't know, 1 2 3 equals 2 3 4, and that of course is going to be false and not true. Yeah, so that's kind of how the post macro works. You know, it doesn't need to be a space right here. As long as it is at the end of a line, it will go ahead and do its thing. So this is going to be useful for testing. You know, you don't have to put assert. You know, this is just a syntax that I chose, you know, to do one certain thing. It could be really anything. It could be like an if statement or like, you know, God knows what. It could be anything. But yeah, that's the post macro system call. So there is another syntax altering system call. It's called syntax. I am not going to go over that one. That one's on the documentation on my website. But I am going to go over the enclosed syntax method, if I can spell. And this one actually takes 4 arguments. And this one basically asks if a line is enclosed by something. So example, if something is enclosed by parentheses, then it will then invoke the function specified at the end. So again, we do need a variable, and then at the end we are going to have the function that does run. So for this one, maybe you don't like using, maybe you think .val is ugly or something. I honestly do think it is ugly. I don't really like it myself. So we want to get rid of that. So we can say that we're going to just do something like this. Maybe it's like, you know, if we find a line that is enclosed by parentheses with a variable inside it, then we will just extract the value and we no longer have to use .val. So how would we do this? So we have the line. We would basically say something .value, so we get the string .value. So I believe we're going to do something like this. We're going to interpret a string of code that's going to be the line. Where did all that just come from? And then it's going to say .val, and I think that should work. Let's try that. And yeah, looks like that works. So we're just printing the value of a variable, and now this is how we're going to reference variables. Array equals 1, 2, 3. Another one. Yeah, so that's just another way that we can reference variables, and this is the enclosed syntax. Yeah, basically just if a line is enclosed with something, then do something with what's inside. So you can probably imagine that there are a lot of cool things that you can do with this syntax altering capabilities that you've been granted. I actually just thought of a pretty cool idea right now, and I'm not sure if it's possible. Well, I'm sure it's possible, but I'm gonna go ahead and try and do it in one go right now. And it's basically just MSNScript2 implementation of list comprehension. And this is the kind of syntax I want to go for. So I'm going to go ahead and try and write this right now. So it's going to have to start with a with and a space. And we're going to go ahead and get the line. And then we're going to do something. So the line is going to be this. So what we really need to do is split in two different places. So we are going to need to first get the variable, then we're going to need to get the iterable, and then we need to get the code body. So we need to get this, this, and that. So getting the variable, so we're gonna say, I don't know, split one. So that's gonna be this first section right here is going to be, yeah, Copilot's got it. Ugh, Copilot's gonna be on me for this. Yeah, so we're gonna split it in. Gonna make sure it does have a space on both sides, and the variable is going to be. Let's actually move this up here. So we're going to split, and then we're gonna get the variable. So the variable is actually going to be the first part right here, and it is gonna have a space, so we are gonna need to trim it. So the variable is going to equal, Copilot is wrong, split one dot get at 0. And we are gonna trim this so that we make sure that we don't have any spaces, or strip in this case. And then we are going to need to get the iterable. But before we do that, we are going to have to split again. Split 2 is going to be split.get1 at that. So we're just going to call this, I don't know, like the second part. And that's going to be split.get at 1. And then we're going to do a split 2. And that's going to be the second.split at do. So we're going to split right here. So the second part is going to be all of this. And we're going to split it do. And the first part of split 2 is going to be the iterable. So iterable is going to be split 2 to get a 0, yeah. And the code is going to be split get at 1. But the iterable we would like to interpret as an actual array, not just a string. So we do have a string, we need to turn it to an iterable, so we're going to evaluate it with the dash system call. So now we do have the code. we have every part that we need to execute the function. So we are going to return a new array. I don't know, I guess I'll call this new. And at the very end, when we are completely done, we are going to return this new array. Comprehended list. And then we will return it. So yeah, we're going to loop through the iterable. So iterable dot each, and this is another method for any iterable. First argument is going to be the value for each, or the variable name for each. And basically for each of this, we need to assign the variable to each one. So we are going to use the var system call, set the variable to the current element. And this takes two arguments. The first one is a string value of the variable to edit, and then the second is just what to put in there. So what did we call this earlier? Variable.val. So the string version of variable is going to just be assigned to whatever the element is. And then we are going to add whatever the executed version of the code is to the new, to the new comprehended list. So new.add, we are going to add an interpreted version of the code. So this all should work just fine, I think. Guess we'll see here in a second. Almost forgot the last comma. So to invoke this big old macro here, we are going to create a test array 1, 2, 3, 4, 5. And what do we want to do with this? Guess it doesn't really matter. We could say with x in, this is going to be array.value. This is interpreted. This is going to be interpreted right here, and it's going to be placed into that iterable. We're going to say do. So all integers do have a multiply, they have an add, they have a subtract, just edits them in place. So we are going to just, I don't know, multiply it by 2 or something. So this should just output a new list with everything multiplied by 2. And okay, it's taking a second. Okay, took a little while. Let's try again. Okay, first run jitters, I guess. All right, well, it looks like that works perfectly fine. And this can probably just be anything now. So it can be probably just some giant. I'm not sure. Integer 2 equals yeah, x and multiply the current x by 2. And then, you know, do integer.val. So a little redundant, but just showing basically what is possible. And that's just going to multiply everything by 2. And it looks like it does work just fine. I do want to try one more. So with x in array.val. So this is basically just going to map the string function to each one. So this is going to instead have, or it's going to return instead of a list of integers, it's going to be a list of strings. So we're just going to return x.stir. So I believe they do have a string method if I recall. And it looks like it does work as I wanted it to. So with everything that I've explained, that's basically the entirety of the language and what it is capable of. I have an unholy amount of demonstrations and pretty cool things going on with the language that it can do. It can do web scraping, multiprocessing again. I do have a little backend API request for ChatGPT. Just, you know, asking it a question. That can be done in regular Python though, obviously. But just kind of showing you exactly what's possible with it. Starting servers, creating a new syntax, all sorts of good stuff. If you want, you can go to my GitHub and check it out. I do have a whole lot of code that I've written myself, and I've been playing around with it for a long time. There's some pretty cool random things you could do with it for no reason. But yeah, again, it's just a concept, you know. Of course, this has no real implementation yet in the real world. Who knows what could be done with it or could not be done with it. But yeah, I hope you guys liked watching. This was just a short tutorial of MSNScript2. I guess I will see you next time.